Okay, so in this problem, we are dealing with a pharmacy that uses a machine that mixes medicine, and there's a concentration that needs to be consistent across several bottles. Since there's a safety hazard if the concentration is lower than 100 parts per minute. So I'm going to kind of put an underscore right there. The pharmacy sets the machine to average 108. And the pharmacies believe that it follows a normal distribution with a standard deviation of 12 parts per million. Assuming that the information provided is correct, what percentage of medicine dispensed by the machine is below the minimum safety level? Well, let's see. If I were to draw this out as a normal distribution, I would say, okay, I know that the normal distribution's average is 108. And they start going like this, but there's something kind of strange here because the minimum safety area is going to be 100, somewhere around here, but there's 12 right here. So I can say a good bit is going to be below this minimum. So the question is how much? Well, let's z-score this so we can find out exactly what percentage it will be. So z-scoring, this 100 would be 100 minus 108 all over 12. Okay, so 108, let's see here, that's going to be basically negative 8 divided by 12. I get negative 0. Well, let me get my pen, negative 0. And then 6, I'm going to say 6, 7. So let's go and find what this gives us. These are positive z-scores. I need my negative z-scores. And let's see, we said negative 0.67. So negative 0.6, and then it goes 6.9, 6.8, 6.7. So I see it's 25.14% when I look right here, 25.14. So 25.14% will be below the safety. Okay, so basically almost 1/4 of all of the bottles. That's kind of a bad idea. So let's see, what do they say here? If we go down to part B, it says, lawyers for the company insist that no more than 3%. Okay, well, right now that's a big issue because currently we're at 25%. So no more than 3% of the medicine can be below the minimum safety. And engineers at the company believe that they could achieve this by lowering the standard deviation. What would the standard deviation of the machine need to be to ensure legal compliance? Whew, okay, well, let's see. If 100 is the cutoff here, what they're basically saying is I need 3%, which is 0.03 is what we need. So as the coloring here, so to kind of draw what I'm thinking in my head, what they're basically saying is that we know that this data score right here of 100 can't move, but we know that the amount of coloring that we color in right here can be 3% of the data. So I need to figure out what is the z-score that would match this. So, okay, let's go and find out. 3%, where do I find 3% in this table? Okay, 3%, I can see 3% is right here. Wait, no, that's not 3%. Aha, 3% is right about here. Well, that's negative 1.88. So negative 1.88 is what I'm going to use for that z-score. So I can say that this is a z-score of negative 1.88. Well, how do I make that happen with a standard deviation? Okay, so let's see. I know that we're going to end up with negative 1.88. The safest minimum is this 100 against an average of 108. And the problem is I don't know what the standard deviation is. Oh, okay, I see how we're going to do this now. Looking at the top, 100 minus 108. 100 minus 108 is just negative 8. So negative 8 over sigma is going to be equal to this negative 1.88 z-score. Well, I'm going to go ahead and put that over 1 so that now I can just cross multiply. So this negative 8 times 1 is just going to be negative 8. And that's going to be equal to the other cross multiplication, which is negative 1.88 sigma. I need to get the sigma by itself. So just taking that, and actually I'm going to erase this and make it look more like an 8 real quick. Negative 8. So to get the sigma by itself, I'm going to divide both sides by negative 1.88. So negative 1.88. And if I do that on my calculator, I get that the sigma that we need to use is 8 divided by 1.88. I get 4.25. So we need a sigma of 4.25. Basically, we really need to bring the standard deviation down. Well, this next question is going, what would a lower standard deviation mean in the context of this problem? Well, remember, standard deviation is how much space there is between these tick marks. If the space between them is getting smaller, that means the machine is giving us less variation. So this means the dose of the machine is more consistent with less variation. That is what it means in the context of this problem.